Okay, I'm trying to record. So I'm going to go with the concepts of data mining and big data today. Then I'm going to demonstrate the concept of discriminant analysis and data partitioning with Excel file. And hopefully that's going to be helpful to understand the concept. So there is a blackboard. So you may know these concepts if you take the course of business information systems. You already know this. Because we collect data, so we'll live in the era of big data, right? So you heard about big data. So using data doesn't give you any information regarding your business decisions, your decisions. So we need to transform data into information. Data be transformed into information. That information will be accumulated to get knowledge on subject matter. So you can be an expert with those knowledge, and knowledge will be based on wisdom. So today we're going to focus on data and information. So data is the key these times, because in the past data was possessed by someone at a higher level, and also some experts. Because if you start to work for retailers and wholesalers, you use barcode. The barcode scanner will collect information of items and customers. So you work with a transactional data. So see this pyramid. The bottom have transactional data, and the managers will use the data set for managing human resource and workflow, things like that. So it is a management will use on the top. CEO and CFO will use the management information. So this is transactional information systems and C management information systems on the top. Export system, or sometimes executive information system, with higher level of information. So when it comes to data, it is on the bottom of this slide. Now, this data. So if you hear big data, this is the adjective. So it's about size, big size of data. Right? But if you go with the uppercase of big data, it makes different. So when it comes to big data, it's not only about size, but also other characteristics. So coding, you can think of 5 bits. So volume is about size. So now using barcode, the GPS, So you use Navigator, right? And use a smartphone, and Google collect your information, and Amazon collect your information. So company is trying to collect your information. So it creates huge volume of data. So it is about size. Then many different types of data, variety types of data. That is being changed so quickly. But yesterday's data may not be useful today, but you never know. So it is about velocity, it is speed. And then make sure the data is informative. It's good data or bad data. So it is about veracity. It's about quality. And then one more view. It is about size, type, speed, quality, and price, value. Data is expensive, right? So now if you accumulate data sets, you need to have a storage. You need an external drive or maybe cloud service, right? And then you need to pay memory to secure the data, right? The value. So it's about value or price. So you need to think about 5 years in terms of big data. So we live with big data. This data is being collected, smartphone, and then website, barcode scanner, and RFID, GPS, navigator, and some. So we have so many different electric devices. And then when you click website, that information is supposed to go to other companies. So that was not considered as a valuable asset in the past. But these days, this data is very valuable. So depending on how you use them, depending on what kind of data you have. So think about five. So there can be strategic assets. Sometimes to make a decision making, right? Then you need to buy the data. You need to pay for it. If you keep the data, you process the data to resell the market. So this is the idea you hear about supply chain. But when it comes to digital assets, you can also provide that and sell in the market. So can digital supply chain or sometimes information supply chain. So you download the music from website, right? Then it goes to your computer, and then you distribute your music to other devices. Definitely you need to consider copyright. So there is a chain to produce the music and distribute the music. Right? So it is about information supply chain or digital supply chain. So using these data, you can go with data-driven decision making. Now, even universities, companies, when you justify what you want to do or what kind of business you want to push, they're gonna ask. So provide data, and then what is the fact, right? So you need to have data to justify what you think. So it is about data-driven decision-making, data-based decision-making process. So this data-driven decision-making will be with analytic techniques. So that's what we're learning about data mining today. It is like a coal mining. You need to find a location and then right place and right product and how to dig into the ground, right? And then what are the quality of the coals and how you distribute the commodity to the market. It is the same process, but we have different commodities. So the data mining will have many different techniques as well. So now, regarding the information, data will be transformed to information. To do that, we use analytic techniques, tools. So we use data mining. We'll have several different techniques. Now, a lot of research is creating more techniques and tools. You can buy some other tools from the market. See, just categorize them into supervised learning and non-supervised learning. Unsupervised learning. Supervised learning includes classification and discriminant analysis. So we're going to go with the discriminant analysis today to see how we partition the data. Then prediction model. We already learned about regression. And then we have 10 years and time series. We cover time series in chapter 11. So these supervised techniques will need response variables. Response variables. You know what is response variables? We have independent variables and dependent variables. You already got a response. So based on response, try to classify or predict. Because you already have answer. You already have answers. So based on those answers, you try to understand what kind of factors are involved. So then you use those factors to predict dependent variables. Then unsupervised learning doesn't have response variables. There's no answer. You just do to answer your questions. So this kind of unsupervised learning will include and segmentation. Okay. So you're familiar with the segmentation, it's like a market segmentation, right? So depend on the behavior, you grouped those customers into different groups. That is a segmentation. You can also use it in geographical analysis as well. So we use quality data and transform those quality data into transformation using data mining techniques. Data mining techniques will consist of supervised and supervised learning techniques. Supervised learning include classification, discriminant analysis, and prediction models. The prediction model include learned in chapter 9 and K-nearest and time series chapter 11. So we're gonna pretty much cover regression, time series, classification, and discriminant analysis in this chapter. And K-nearest, if you have extra time, we're gonna cover that. That is a very popular one in my research. And then unsupervised learning will include segmentation and association techniques. So you hear about ChatGPT and machine learning and artificial intelligence, neural network. So all these kind of things are related with these kind of techniques and concepts. So we can, the data mining, using the data, you try to understand, try to get your business answers. So there are processes for data mining. First, you need to identify your questions. If you don't have questions, you're not going to do anything because you don't need answers, right? You need to have a business questions. Identify issues, hypotheses, what you want to know. Then collect data to answer your question. The data should have quality and reliable and full data set. Definitely, you cannot have a population. That means you cannot collect all the information you need. You need to collect sample out of a population which represent the population. That is an accuracy. So you need to get a right size of sample data, and then you clean the data. And if you need to fix some of data, you need to fix it. And then you can have category to binary variables, like we learned last time. If you have three different, right, good roof, medium roof, bad roof, then you need to n-1 binary variables. So I'm going to demonstrate with Excel file. Then once you have a data, you need to have right tools, right techniques. If you can write the code, you can create, but if you don't have, you need to buy of software. Then you need to, right? Then once you have solution with applications, you need to validate your model. The model should represent the real world. So it is about another. Then if you able to to your business and then implement. Once you implement the software, you need to have a right person to run the model. You need to train the people. You need to maintain the software. You need to have a right maintain the server to ensure the so and then store the data. Still not done. You need to have continuous improvement because the business is being changed, data set will be changed. You need to of the data and model. Okay, so when it comes to model, we may say there is algorithm. What you need to do is you have a sample data, or this is population, so you have parameters. So you collect sample and then estimate them. Using technique. Again, parameter include mu, standard deviation, and variance, standard deviation, and some other parameters, while statistic include average, standard deviation, and variance. So you use different inputs. So using these samples, so you cannot collect each sample because it's costly. Sometimes you need to buy the data, right? So you cannot buy whole data set, very expensive. So you need to buy small size of sample data. Once you have a sample, and then you have many observations. Right? So these data mining process need 3 processes to make a reliable model. Calibration, validation, and test. So calibration is the process to change parameters to make the model meet in the real world. The validation, once you have the model and then run the model with data set and see how accurate is it. Then test with the other data set to make sure, to ensure your model will be applied to your business situations. So calibration will need training data. Because ChatGPT was released, I think it's just a couple of months, right? And then actually before that, but the people start to use it and train the algorithm. Data. And test when you test the data set. So how would you get each data set with the sample? You only have one sample, only one sample. Then you need to split the sample into training data, validation, and test data. So 3 data sets should have different observations from the same sample. For example, if you have 100 observations from this sample and only training observation will be used for training data, then training for validation process, and then the other things can be used for test. You need to split the sample into 3 different data sets. We call it partitioning. Fission. So another question is, if you try to buy data set, or if you need to collect to answer your business questions, what is the right size of the sample? So you need one observation and 200 observation. So in general, if you have key number of variables, in your model, you need to have time 10 or 15. So if you have 10 variables, you need to have sample size 100 or 150 at least. So if you have a bigger sample size, it is going to represent the population better, so you have a better solution. So do you have any questions so far, or any comment? No? So so we need to be careful when you have variables. I think so. We mentioned that in chapter 9. So if you have a number of variables and some of the variable will have a strong correlation, right? For example, now see, you have X and Y. Then if you take a look at the data and it has a linear pattern, right? Then if the correlation is 1, that means a strong correlation, positive. And if you're downward, then strong correlation, negative, right? Then you also see correlation is 0, there's no correlation. If you have a strong correlation between variables, you may need to choose one of them. Not all variables will be used for your model. So we need to check correlation using correlation metrics or multi-collinearity. So Excel provides a feature of correlation. So we may able to create a correlation table. And then another issue is if you have categorical variables, you can say roof, good condition, medium condition, bad condition. We have 3 different possibilities, and if good is 1, medium 2, bad 3. So this is not the weight. So this is the only represent the words. So we need to convert these into binary code, which is dummy variables. So we have 1, the dummy 2. So we need to pick one of them and baseline variables. Let's say, and if the condition is good, we say 1, then dummy is 0. If the medium, domain 1 will be 0 and domain 2 will be 1. If you have a 0 for both, that means condition is bad. Make sense? Yeah. So we need to convert these categorical variables into domain variables with the binary. Then sometimes you need to normalize the data. Some data will have units, kilogram, liters, pound, mile, something like that. But if you want to mix different units, you need to normalize with unit list measures. So you need to convert to dollar value. Then you have both dollar signs, or maybe you need to convert into ranks. Right? So you may have different ways. So normalization will be needed sometimes, depend on your questions to answer and data sets. Okay, then I think I'm going to use Excel to demonstrate. Amazing. 26. Okay, let me open slides first. Excel. Okay, can open here.